We talked just about watching this quick video on a flipbook example. We go back to this slide that gives you the big picture overview. You say the variable exists, then you initialize, you give it a starting value, and this is conceptually the weirdest part because it's so different than math. You modify it or somehow update it, x equals x plus 1. It works a little different in computer programming compared to math. We may think that, let's solve for x. You subtract x from both sides, and you end up with 0 equals 1. Does not compute. What the heck, Mr. Chan? That's okay. It makes sense in computer programming. We may or may not get to if statements. It's this part about variables that's essential. But we take a step back. We talk about expressions. Whether you were in CodePen or in GameLab, know that somewhere along the lines, especially for your national flag assignment, you started using multiply, divide, add, subtract to shift your shapes over instead of like deleting the number and replacing it all. That's called using expressions as arguments of your functions. So like over here, you know that the first two coordinates determine this ellipse has a xy position of 150, 150. It's about 200 wide and about 240 tall. This stuff is legal. It helps saves you time because the computers can do this calculation for you. Why do it yourself in your head and modify it like with so many keystrokes? How is that handy? Well, symmetry is really easy to implement. If you have a line down the middle, whatever that is, the line's at x equals 150, by subtracting it, you have one image on the left-hand side, and adding a set amount, you have the symmetric image on the right-hand side. So using the same difference from a given like line or point, you can easily implement some kind of symmetry, whether that's just across the x-axis, the y-axis, maybe across some kind of line. It looks pretty neat. You may want to use this idea in your shape pattern assignment. But even more so, we want to be able to do more complicated kinds of change. That's why we need variables. The first vocabulary word you'll need to know, and it will be on your quiz, is declaring a variable. You must say it exists. In JavaScript, in GameLab, it looks like using the var block or typing out this keyword, var. You put a space, and whatever follows will be the name of your variable. In this case, I have a variable called num, probably short for name or number, and then a semicolon. That's the declaring step, just saying it exists. My mailbox, using that analogy, doesn't contain anything right now. It's just ready to be given value. When you use the equal sign that we call the assignment operator in computer programming, now it has a value. What do you think num is? You think, yeah, like, 5, right here. This is called declaring, giving it a name, and then initializing, giving it starting value. That is called initializing or initialization. This vocabulary word will be on your quiz. As we are lazy computer programmers, of course there's a shorter way to do that. You can do var num equals 5. You've declared it on the left-hand side, and now on the right-hand side, you've given that new variable, num, a value, 5. So to test your understanding, where will this ellipse be drawn? Var value 1 equals 17, var value 2 equals 13, and then we use it in the ellipse argument. Can you calculate those numbers? We think through this. We see value 1. Where's value 1? It's just substituting in for 17 right now. So its x-coordinate is 5 plus 17, which gives us 67. Your y-coordinate, we look for value 2. 50 minus 13, 37. 67, 37, width of 12 pixels, as tall as 44. Not so bad. A little bit about that initialization step. The equal sign, it's not like math. The left-hand side isn't the same as the right-hand side. Notice this syntax is proper. This spelling and use of num equals 5 is the correct way to initialize. If you flip it the other way around, it doesn't work. Because this equal sign takes what's on the right-hand side and then puts it into what's on the left-hand side. when it tries and thinks you'll get an error message. And variable, this num variable, assuming it's declared, doesn't contain anything. And 5 already has a value, so this is an error. This will be on your quiz. I'll say this is the proper way to initialize a variable, in which case you say false, or you say why it's wrong. Okay. Maybe you think that since we can do declaring and initializing in the same step, you can do something like this. That's a little bit too much. Unfortunately, you have to break up these two lines. The ellipse function right here is trying to, this should be var, but it's trying to initialize, declare, and use this x variable. Way too much. You got to separate that into two lines. Declaring and initializing can occur in one step, and then using it in the later function down here, 45. We'll take this spot. Now here's the new stuff. X equals up x plus 1. I call it the updating step or the modifying step. This is the new part. It looks a little weird. So let's walk through an example. Var x equals 3, and in green afterwards it says x equals x plus 1. What do you think the value of x will be? Tick, 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 tick. If you're thinking 4, that is correct. 3 is initially put into the right-hand side. Imagine 3 plus 1. And then 4 is stored into x. So at this point in your code, x will have the value 4. At this point, var is still 3. Before here, var x doesn't exist. And you can use this in neat ways. For example, like having the offset variable being used, you can now offset 4 different ellipses and have like 4 times the symmetry. And for this one, I didn't create an answer for this. So this is the original quiz question, where there's red, there's x and y. This one's x, this one's x, 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 oops, x, y, x, and y. Think through this question, see if you can figure out is it the top picture or the bottom picture. And then I have a slide down here that talks about it. You can consult the Block 4 video where I walk through why that works. But let's see a more complicated coding example. So in this line, I want to emphasize that modify step that's occurring. We'll focus on the ball that's going from side to side, which I call my rolling ball, this one that my mouse is tracking. How the heck is that being animated? So when we think about the kind of change that occurs, it's one-dimensional and it's only along the x-axis. See, the y-axis, the y-coordinate stays the same. So over here, on line 21, it says ellipse, x rolling, y rolling, 24 and 24. Let's see what our initial values of x rolling and y rolling are. We scroll up. Look at that. X rolling is at 0, so it starts at the far left hand side of the screen. Y rolling is height over 2, so it starts in the middle of our canvas. Then we scroll down, we look down here. X rolling equals x rolling plus 1. Each time the screen is drawn, it changes and moves over 1 pixel. But you're like, wait, Mr. Chan, it's moving. I don't see that evidence. That's because we're drawing the background over and over again, which covers up some of that unwanted mess. Notice here you have that circle kind of working like a sticky stamp. It keeps stamping, keeps going across the screen. It's quite a large screen. And it keeps drawing. You'll notice that it comes back and you see a slight gray circle that I'm trying to track with my mouse. It doesn't look as cool though. In order to get that sense of animating, you have to start with a clean page, and that's what background's doing here. The draw function happens again and again and again. When you were drawing your national flags and animals penguin assignment, you were drawing shapes that were always in the same spot. So those penguins, animals, Magikarps, Pokemon, and other things were all being drawn exactly on top of one another. And as soon as you use some variables and update it ever so slightly, whether that's +1, -1, times 2, divided by 3/4, whatever it is, then you enact some kind of change. That's all. declare, initialize, and otherwise modify are the key vocabulary words you need to know about variables. Ta-dang. So the rest of the time is yours to code away. I'll be here to help you.